Dear students, today we will talk about matrix method in paraxial optics. But before that, you need to know about few things. One is ray optics, another is wave optics. See, whenever we consider that light travels in straight lines, so light travels in straight lines, we call it ray optics. The study is called as ray optics. Under this, we study such phenomenon like reflection of light, refraction of light, and all these things come under the category of ray optics. But when you consider the wave nature of light, and under this category, you read such phenomenon as interference, diffraction, so this falls in the category of wave optics. The next important thing that you need to know is geometrical path and optical path of light. For example, if light moves from one point to another, this distance will simply be called as geometric path, GP I call it. Now this medium can be water, it can be air, it can be glass, it can be anything. But the actual distance that light travels from one point to another point in a medium is called as a geometric path. But we know that densities of different mediums are different. We know that densities are different. Therefore, the velocity of light is different in different medium, right? So, if we consider the refractive index of medium, then we will also talk about optical path of light. Optical path of light. And how is optical path written? So it is written as, for example, if mu is the refractive index and x is the distance traveled from one point to another, then the product of mu and x will be called as optical path. Okay? And you should remember that light travels same optical path, same optical path through different media through different mediums, okay, in a given amount of time, in a given time. फॉर एग्जाम्पल अगर हम 1 मिनट का टाइम कंसिडर करेंगे वाटर में भी, एयर में भी, ग्लास में भी, और लाइट ने कुछ डिस्टेंस ट्रैवल किया होगा एक पॉइंट से दूसरे पॉइंट पर, और हमें पता है कि इनका रिफ्रैक्टिव इंडेक्स अलग अलग है, लाइट की वेलोसिटी भी इन तीन मीडियम्स में अलग अलग है, तो लाइट ने एक जैसी डिस्टेंस तो ट्रैवल नहीं की होगी, ज्योमेट्रिक पाथ एक जैसा नहीं होगा, लेकिन एक जैसा क्या होगा, ऑप्टिकल पाथ. द प्रोडक्ट ऑफ म्यू एंड एक्स विल बी सेम. दैट मीन्स mu1 x1 in air, mu2 x2 in glass, mu3 x3 in water, they will be same, and this is called as optical path. Now you remember what is ray optics. Here we consider that light travels in straight lines. We study such phenomenon as reflection and refraction. Then we consider wave optics when we start considering the bending of light or wave nature of light. Here we study the phenomenon of interference and diffraction. Then I have told you something about geometric path and optical path. Now, the next important thing that you need to know is Fresnel distance. Now, because I am telling you that light travels in straight lines or it bends. Now, you have to remember that there is a minimum distance. The minimum distance which a beam of light has to travel before its deviation from straight line path becomes visible. That distance is called as Fresnel distance. Okay, for us, for common observation, light travels in straight lines, but after traveling a certain distance, the bending of light becomes visible, appreciable. So that distance is called as Fresnel distance. That Fresnel distance is denoted by this ZF, and it is given by a square by lambda. What is A? A is the width of the slit through which the light has to move. Because generally whenever we see the bending of light, it is whenever the light passes through certain slits or small holes or small apertures, or when it bends around the edges, right? When it bends around the edges. So the wave nature of light becomes visible there. And the Fresnel distance, again I am repeating, it is the distance after which we can appreciate that light has started bending. Okay, so this is a square by lambda, and lambda is the wavelength of light. Now we humans are the observers of everything. We have to consider that when will this phenomenon become appreciable for our own eye. For example, if we take the diameter of human pupil, diameter of human pupil, roughly it is 1 millimeter. हमारी आंख के अंदर जो लाइट चली जाती है वो जिस प्यूपिल से जाती है उस प्यूपिल को भी हम एक स्लिट के तौर पे मान सकते हैं. और व्हाट इज द diameter of that? It is 10 raised power minus 3 meter or 1 millimeter. And what is the wavelength of light, visible light? Wavelength lambda of visible light, all of you know that it is how much? It is 6,000 angstrom units. So it is 6 into 10 raised power 3 into how much? Into 10 raised power minus 10, because you know that angstrom is 10 raised power minus 10 of a meter. So it is 6 into 10 raised power minus 7. Now when we start giving values here, if we want to calculate the Fresnel distance for a normal human eye, for a normal human eye it is a square by lambda, and when you give value of a and value of lambda, this comes out to be 1.67 meter. Okay, therefore we can say that bending of light, unless it does not travel the distance of 1.67 meter, it doesn't happen. And it happens by how much? Only 10 raised power minus 3 meter, which is quite small. Therefore in our normal observations or normal sight or observations, we do not consider the wave nature of light. We do not consider the wave nature of light. फिर से मैं समझाऊंगी हम वेव नेचर को क्यों नहीं कंसिडर करते हैं अपने नॉर्मल ऑब्जर्वेशन में. क्योंकि इतना डिस्टेंस लाइट को ट्रैवल करना पड़ेगा इतना डिविएट होने में, और ये जो डिविएशन है ये बहुत कम है. वी कैन ऑल्सो नेग्लेक्ट इट. इसीलिए जब डॉक्टर आपका स्पेक्टिकल बनाता है या आई ग्लासेस बनाता है जो हम चश्मे पहनते हैं, उसमें डॉक्टर जो है वो वेव नेचर ऑफ लाइट को कंसिडर नहीं करता. वो सिर्फ क्या करता है? रे ऑप्टिक्स को कंसिडर करता है, दैट लाइट ट्रैवल्स इन स्ट्रेट लाइन्स. राइट. Now after having the knowledge of all these things, ray optics, wave optics, Fresnel distance, geometric path, optical path, we can come to the main topic, that is paraxial nature of light. ठीक है. Paraxial में हम क्या करते हैं? We consider a lens. Now this is the pole of the lens, and we know that the light, the axis that passes through the pole of this lens is called as principal axis. Now we consider another ray of light, okay, which is not straight but it is at certain angle to this principal axis. On this ray of light we consider any 2 points, say this point is A and this point is B. Okay, the coordinates here are lambda 1 y1 and the coordinates here are lambda 2 and y2. The distance between these 2 points is D, capital D. Okay, now if this angle is very small, we consider that these angles are very small, alpha 1 and alpha 2 at these points. These are the angles which this ray of light makes with the horizontal axis. Okay, so alpha 1 is equal to alpha 2 and we can call it, this is equal to alpha. Right. And all of you know in your previous classes that when angle is small we can make use of these approximations, that sine alpha is equal to alpha, tan alpha is equal to alpha, and cos alpha is equal to 1, because when alpha is quite small, cos 0 is how much? 1. Sine alpha is how much? Alpha. Tan alpha is how much? Alpha. Right. Now because I told you earlier about this optical path and all this thing, that optical path will be mu into x. By the same logic, we can say that this lambda 1 will be mu times alpha 1. Lambda 2 will be mu times alpha 2, right? Because lambda 1 we are using, basically the coordinates should have been x1 and y1, x2 and y2. But it is preferable to use lambda instead of x for light, because light has certain wavelength, right? So it is preferable to use lambda instead of x. And then y is the vertical distance from the principal axis. This is y1 and this is y2. ठीक है ना? So we have made use of these relations because I have already told you about geometrical path and optical path. So lambda 1 is mu times alpha 1 and lambda 2 is mu times alpha 2. And because we know that alpha 1 and alpha 2 are nearly same, so lambda 1 is equal to lambda 2. This is another thing. Now next equation would be that this y2, how much is this y2? This y2 is obviously y1 plus this much of distance from this point to this point, right? Now what is this distance? For example, I call this point q and here it is aq. Okay, so it is aq, this distance. I can find this AQ from this right angle triangle ABQ. And in this right angle triangle ABQ, what is tan alpha 1? Tan alpha 1 is perpendicular, that is AQ by base. How much is base? It is D. AQ by D. So AQ is D tan alpha. Again, we are using this approximation that tan alpha is equal to alpha. So it will be alpha 1 D. Tan alpha will be alpha 1 and D will be D. So AQ is this much. Now we use this value of AQ in this equation. So y2 gives y1. For AQ, what will be right? Alpha 1D. So it is alpha 1D. Now at this point, I am multiplying and dividing by mu. Okay. Now what is this alpha 1 mu? This product of alpha 1 and mu. It is how much? Lambda 1. So I write lambda 1. Then it is D by mu. Okay. Now let me try to arrange these equations. How much is lambda 2? Lambda 2 is simply lambda 1. But I can say that the coefficient of lambda 1 is 1. And if I also want to introduce y1 in this, the coefficient of y1 is 0. y1 into 0 is 0. So lambda 2 is lambda 1. Okay. Now if I want to write y2 in this proper manner, so what is the coefficient of lambda 1? It is D by mu. And what is the coefficient of y1? It is 1. So I have basically rearranged these two equations, y2 equation and lambda 1 is equal to lambda 2 equation. Now I can try to put it in the matrix form, that lambda 2 and y2 on one side, this will be a column matrix. Here lambda 1 and y1 on another side, another column matrix. Then I will write a matrix of coefficients. What are the coefficients? 1, 0, D by mu and 1, again 1. And what is the determinant of this matrix? 1 into 1 is 1. You understand determinant? So 1 into 1 is 1 minus 0 into something, this is 0. So this is 1. Determinant of this matrix, I call it T, translational matrix. So determinant of the translational matrix is how much? Equal to 1. The importance of this matrix concept is that we can find the coordinates of any point of a ray if we know the coordinates at other point. So you can relate lambda 1 y1 with lambda 2 and y2. And this is how we use the matrix method in paraxial optical system. The only condition in paraxial optical system is that the angle chosen is quite small. The angle of the ray with respect to the horizontal axis is very small, right? So I hope that gives a fair idea of this topic.